allow folks to answer a simple question in the poll. Basically, are you using console? Are you using Istio? And by console, I mean console service mesh. Are you using Istio? Are you looking at Linkerd? Any of the other cloud vendor service meshes? Take a second to give a quick answer on that. And the poll will be open during the talk, so you can continue to respond. But thanks for joining my session, How to Choose a Service Mesh. I'm coming to you live actually from Phoenix, Arizona. My name is Christian. I'm the field CTO here at Solo. I've been involved in helping organizations build microservice style architectures and adopt containers and Kubernetes and other cloud native infrastructure to improve their ability to deliver software. I've been involved with the Istio community and the Envoy community for about 4 years now, even before Istio was generally available. I've written some books, currently writing Istio in Action for Manning, which I hope to be done with very soon. And you can find me on these social media channels. But I came to Solo specifically to work on this problem of modern service or application connectivity. And Service Mesh is a piece of that story. Now, if you're familiar with Service Mesh, or you've heard the term, or you've come across some of these projects or products or offerings from some of the cloud vendors, you'll know that, first of all, this is a slightly confusing space and crowded space. So some of these service meshes you see here have been around for a while, the Istio, Linkerd, and so on, and some of them are fairly new. And you are tasked with, first of all, understanding what a service mesh does, how these might differ from each other, and then if you're going to adopt one, when's the right time, and how to adopt one, and also understand what are the trade-offs, what are the differences, and how do you pick one that's right for you. So a service mesh is a pattern of solving a distributed communication problem. These problems are around telemetry, observability, understanding what's happening in the system, securing the network between the various services, and then overall controlling the traffic and being able to shift the traffic at runtime without impacting any of the services and without regard to what language the services are written in. Just like containers help package applications and ship them across different environments without regard to how they're built or what language they're using, Service Mesh does something similar. And the way it does that is by installing this little agent or this little proxy next to each workload. And that proxy handles the network communication between the workload itself and the rest of the network. So communication goes from the workload to the proxy and then out to another workload, which on that side might go through another proxy. And this communications mesh is made up of these proxies as intermediates or interceptors in the network. Now, a service mesh does solve some very challenging problems, especially when you're deploying into a cloud environment, a Kubernetes, an ephemeral container environment. Things like service discovery, being able to find services, do client-side load balancing if things start to fail, route around them, traffic control and shifting for things like canary releases, policy enforcement, intention-based access control, and then things like service resilience, timeouts, retry, circuit breaking, and doing this in an app-agnostic way, and doing it for any app that gets deployed. Now, you have to decide whether your environment, you need a service mesh. Do you need a service mesh, I guess? And really, only you can answer that. You have to understand your environment enough to know that, are you building and deploying microservices? A lot of different services. Are they written in different languages and use different frameworks for a particular language? Now, knowing and understand whether you have this problem, is, like I said, unique to you, because not everybody has this problem. Some folks are either not deploying microservices, or they've standardized on a particular language and they don't deviate from that language, and they're able to solve some of these networking problems that way. Other groups don't use containers and cloud infrastructure. So it's another bullet point to understand that the networking problem has existed for a long time. It just becomes exacerbated now. The more smaller pieces we have that are being deployed and that are communicating over these networks, these cloud networks, untrusted, unpredictable cloud networks. So if you're deploying in containers where things are shifting and ephemeral, coming and going, scaling, highly decentralized, then you might consider that a service mesh will help you in your day-to-day operations and actually simplify those operations. Some architectures are built on messaging or reactive or some of these proprietary protocols, RSocket, and so on. They might not be good candidates for a service mesh, and they might not have the problems that that you see, or they're solved differently that you might see with more RPC style, gRPC or REST-based services, of which we typically see a lot of those different architectures. And lastly, with all the different languages and frameworks that you might have on ephemeral infrastructure that use these gRPC or rather RPC style communication across a lot of different services, across a lot of different boundaries, managing that, applying security policies to that, keeping those things consistent, understanding when things partially fail, how to debug them, how to figure out what's going on. Building the infrastructure yourself to do that is a tremendous task. And this is an area that service mesh can help. So before deciding which service mesh, decide whether a service mesh even is applicable for your environment. Now, another thing that we've seen with folks adopting this type of technology is maybe they don't need a service mesh right away, or maybe they need some of these features, but they don't need to deploy service proxies with every single service instance and so on, or they want to start small. And an approach that they take is to use some of the common technology like Envoy and use that at strategic gateway parts of their architecture, or a service mesh light. I've heard some people call it, or I call it waypoints, right? So as traffic's coming into a system, giving it some structure, giving it some consistency in terms of security or traffic control. Waypoints comes from aeronautics, I guess, where pilots are flying a flight plan and they're looking for various waypoints in their flight plan to make sure that they're going in the right direction. Now, having these proxies allows you to give your architecture some structure, to abstract away details like, well, is this a monolith or is this a microservice or functions as service and so on, and give you some of the benefits of what you might get from a service mesh, but without going all the way toward a service mesh architecture if you don't need it yet. So maybe you're going down this path and you're trying to decide, well, is my environment suitable? Do I need a service mesh for this? Some things to watch out for that might indicate that it is a good idea to go down the service mesh path, and that is you're growing your number of services, your microservices. You're deploying into these cloud native platforms or adopting them, including them. Maybe you have VMs as well as physical hardware, and then you're introducing containers and maybe Kubernetes. If you find yourself are already maintaining multiple languages and multiple frameworks, libraries that solve problems like circuit breaking and distributed tracing and telemetry collection and client-side load balancing, it's time to start exploring how to operate your services with a service mesh instead of continuing to invest in that. If you see yourself building and maintaining custom or bespoke frameworks for handling certificates and shuffling certificates around, or you find that the service communication the telemetry collection between your services is sort of a black box, and you're afraid to make changes because you don't know exactly how this is going to impact the rest of the system. It might be worth investigating how a service mesh might be able to help with that. And the last piece is, do you have the supporting infrastructure to make adopting a service mesh successful? So things like Git, like source control, like CI/CD pipelines, to be able to make changes to get into a production environment. Things like the supporting infrastructure like telemetry, time series databases, Prometheus, Grafana, CloudWatch, Stackdriver, these types of things for collecting logs, maybe distributed traces. So having these as foundational pieces for operating a microservice style or a cloud native infrastructure are strong pieces, supporting pieces that you would need to operate and successfully deploy a service mesh. So if you thought through whether or not a service mesh makes sense for you, or you're moving past some of the initial stages of adopting this cloud native technology to build and support your microservices, then you get to the point of actually selecting a mesh. Now, this is a big step because a service mesh, once it's deployed, is in the request path of your application or service traffic. This is huge. This is a critical piece of infrastructure. And having an outage or having some issues with it can significantly impact your ability to deliver on business outcomes and other business goals. So selecting a service mesh is not a trivial thing. It's a very important piece to your application puzzle. Now, you have options. As we saw in the previous slide, there's lots of different service meshes. And you might think about this in terms of, well, am I going to take a service mesh and run it and manage it myself, which some folks do with, let's say, Kubernetes? Or will you offload that to a public cloud or some cloud provider or something in between, right? Because there's the you can go take a service mesh off the shelf and install it and run it yourself. You can get it with a platform provider, something like you see from VMware or Red Hat or Google, that they have it baked into their Kubernetes distribution. Or you can go get it as a managed service on a public cloud. And as you saw in our keynote, now with Glue Cloud, you can take a service mesh Istio to any cloud and get it managed. Right, so there's quite a few different options for how you might consume or adopt a service mesh. Another point that you might want to consider is the technology that the service mesh uses itself. Is it using Envoy proxy or something else? Envoy proxy has become the de facto standard for building this type of L7 dynamic cloud native application infrastructure, from things like edge gateways to service mesh to shared gateways, and even actually beyond that, beyond the edge. And Envoy is where a lot of the innovation is happening. How traffic gets routed, what protocols get supported, how to extend the data plane with things like WebAssembly. The innovation's happening in Envoy, and that innovation lends itself to the service mesh feature set as well. So if a service mesh is using something like Envoy, then it can take advantage of those things automatically. Now, if you see what's happening in the service mesh ecosystem, including what's happening at the proxy level, you don't have to look that far back to see something similar and see what happened in the container wars or container orchestration wars, right? There was Docker, and a lot of different systems adopted Docker, but not everybody did. Some folks said, no, we're focused on, if I remember correctly, the Cloud Foundry folks said, no, we're going to focus on developer experience, make it super easy and all this stuff, but we're going to use our own container format, garden containers or whatever. Because why? Because it's special built, and that's That's what it best suits our architecture and so on. You're seeing the same thing play out right now. Kubernetes won the container orchestration wars. Docker won. Envoy is winning, if not has won. So deciding what technology is actually underpinning your service mesh is actually pretty important. And you can see some of those that have gone off and done their own thing. The next thing you want to explore, since service mesh is a critical piece to your cloud native infrastructure, is maturity and how widely adopted they are. And are they solving the use cases? Are they stable? Are they, enterprise use cases are, they typically take a technology and push it to uncomfortable extremes for what that technology originally envisioned. And you can kind of see on this diagram that things like Istio have been around for 3.5 years and have been pushed to its extreme and is constantly, up until now, being, the innovation's happening there, the bugs are getting solved, the new use cases are coming up and being solved. Istio is extremely mature. Some of the newer service meshes that have entered the scene haven't gone through that hardening and vetting process. In my own personal anecdotal estimation, it takes at least 2 years for a service mesh to be introduced to the market, actually going through this hardening process to the point where you can say, all right, yeah, we can comfortably run this in production. Another aspect that you want to keep in mind, especially knowing the backdrop of that criticality of the infrastructure, is who's going to support it. Who can support it? This technology isn't trivial. Microservices themselves, that architecture is not trivial. Do you have can you rely on someone with expertise who can help you, and especially when things go wrong, can they support it? Can they patch it? Can they deliver hot patches and fixes? Can you call them at 2 o'clock in the morning when things go down? And something like Istio, which you might notice a common theme here, has been through that process. Lots of different large vendors, small vendors, Solo included, support Istio in production. Other service meshes are backed by either smaller or just individual companies, or cloud providers, right? And you're at the mercy of these individual companies to try to support a service mesh, and some don't have any support, or at least not yet. Now, a leading reason for why you might want to adopt a service mesh, as I've mentioned, is running on ephemeral cloud native infrastructure. Kubernetes is one example of that. And if you're running in Kubernetes, you're already halfway there to probably needing a service mesh at some point. And so it's not a surprise that some of these service mesh offerings do have really good Kubernetes support. Being able to inject the sidecar next to your workload in Kubernetes so that it becomes part of the pod, actually running the control plane, running all the components, and managing them the same way you would any other Kubernetes workload. Being able to run on a public cloud Kubernetes, or your self-managed, or a prepackaged vendor Kubernetes, and so on. So, like I said, it's not a surprise, but Kubernetes support is where a lot of the service meshes typically do better. Now, what about non-Kubernetes support, or being able to run in hybrid environments? There are some service meshes that don't do anything outside of the Kubernetes environment, and then there are some that are sort of came from the genesis of their origin was in non-Kubernetes environments, and then they're moving backwards toward Kubernetes. And then something like Istio is, started on Kubernetes. It was Kubernetes first, and then slowly moved toward VMs, but now has first-class citizen for VMs. Now, the VM-based workloads are probably not where you're going to start to deploy your service mesh, but they can't be excluded. There's likely more VM based services than there are container-based or Kubernetes-based services, especially in a large organization. But managing a service proxy, managing certificates, managing the integration with other supporting infrastructure like telemetry and logging and so on a VM is a lot more tedious and a lot more automation that typically has to be written to enable that. So finding something that runs in your environment is extremely important and will be very specific to the way you run your services in your environment. My personal observations, as I've said, and you can tell, there's, I've been involved in the Istio community for quite some time. When I came to Solo originally was, we had super glue, and we were focused on simplifying any service mesh adoption. And what we saw through our customer base and the ecosystem in general was that originally people were kicking the tires on everything, looking at everything. But more recently, I would say within the last year, the market has started to coalesce around Istio. Istio is becoming the dominant service mesh that people are adopting, deploying into production, which also manifests itself in some of these observations that we saw earlier, that it's extremely mature, that it is supported by multiple vendors, that it's got strong Kubernetes and VM support. And generally, the observations I think that we have is Istio is going to be the leading, or if not is, the leading service mesh that folks adopt for self-managed use cases. And we believe, with the announcement of Glue Cloud and other things that we'll show, the leading service mesh for managed use cases as well. And so you'll see throughout the show here at SoloCon that Istio has become a focal point of these solutions, and that if you're going to seriously evaluate whether a service mesh is right for you and which one to pick, then our suggestion is start with Istio and say, why not Istio? And then figure it out from there. So let's say you've gotten to this point, understand these points that I've made here. Where do I start? One of the things I think that people point out is experience, developer experience, these types of things. There should be no trade-off between using an Envoy-based service mesh and a service mesh that has a good developer and user and operator experience. But when people take this technology and actually deploy it and get past that initial kicking the tires and the debating experience and all that stuff, where do you actually start? How do you actually go to production with these types of things? It typically starts at the edge, getting the control plane deployed into your cluster, understanding how to operate it, how to integrate it with the rest of your infrastructure, deploying an Envoy proxy at the edge. That's a familiar area, and using it to route traffic, to secure traffic coming into your clusters. Now, starting at the edge, not every service mesh has this opportunity, this option. All right, some service meshes don't have an edge ingress gateway. Now, for those, or even for those that do, we've built Glue Edge here at Solo, which you may have seen in the keynote or somewhere. That Glue Edge is specifically designed to fit in this scenario. But if you have a service mesh that has an ingress gateway, that's typically the right place to start. After that, you need to focus on what is the high value use case that you can deploy and operationalize and start to see the benefits of initially. Don't try to, I'm sure I've been saying this for years, you've seen this other places maybe. Don't try to put the mesh in and adopt everything all at once. Typical initial first step use cases that we see are folks either trying to get traffic into their cluster using ingress. So that's, as I said in the previous slide. But then after that, securing their service communication traffic for compliance reasons or other reasons. So enabling mutual TLS, if not between services, just from the edge to the first hop as sort of a first step. And then starting to explore using authorization policies and so on. So focusing on security as sort of the first few steps into the service mesh is fairly common. Another one is surfacing telemetry or the golden signals. The communication that's happening between services, the failures, the throughput, latency, these types of signals about how the system is operating. And then my personal favorite is to be able to control traffic and do canary releasing through percentage-based routing or content-based routing, dark launches, these types of things. So I guess ultimately pick a use case that you're trying to solve and introduce the service mesh, introduce the control plane, maybe the edge gateway or the ingress gateway, and then pick off some of these high value use cases. So what we're doing at Solo also, not coincidentally, aligns with this sort of adoption journey, which is start with your gateway, start with the edge. That could be a full-featured API gateway like Glue Edge, or that could just be a Istio Ingress gateway if you just need traffic into your cluster. And then slowly adopt the pieces of the mesh that you need. We at Solo support Istio and can support it for you in production, apply security patches for much longer than the community will. We have FIPS supported or certified builds. We build for ARM-based architectures, Graviton on AWS, do architectural reviews, and so on. After that, you're probably going to build user workflows on top of this. How do you get services into production and align that with the control of the traffic? How you extend the data plane, maybe using something like WebAssembly, and then do that across multiple clusters. So you've seen what we're doing with Glue Mesh, which is a distribution of Istio that supports and simplifies running across multiple clusters. So getting from, hey, I have Kubernetes and a bunch of microservices to successfully adopting a service mesh is something that we're very focused on here at Solo, and aligns a lot with what I've been saying over the last four years. And so ultimately, what a modern application platform might look like is heterogeneity is given. Using containers, Kubernetes, along with VMs, functions as a service, and then layering in the service mesh or edge gateway capabilities on top of it, with the ability to extend it and tie into all of the various infrastructures that you might choose to run on. Maybe you choose to run some workloads on a public cloud with a particular version of a service mesh, and maybe on-prem a different Kubernetes distribution with a different version of Istio. Simplifying and tying all those things together is exactly what we do here with the Glue product line, hence the name Glue. And we focus on getting folks up and running with a service mesh. So at this point, I will thank you so much for joining us here at SoloCon, and I'm happy to take a few questions. Let me see, where are they? And then, so for the poll, actually, let me just point out that our users responded overwhelmingly. 80% of users are either using Istio or considering using a service mesh that's Istio or Istio based. We have about 5% for console, 5 for Linkerd, 5 for app mesh, and 5 for Trafic, give or take. It's not exact, but and that response, I guess, aligns with what we've observed in the community as well. So let's see here. We have some questions. Oh, thanks. There's the poll. So somebody made a comment, Istio wins so far, but you need to understand that everyone has their own tasks and their own evaluation criteria. There is no silver bullet. And that is 100% correct. At the API Gateway, you can do things like server discovery and can deploy the control plane in VM or on Kubernetes. If you are using a VM, then something like console is helpful. That's just Steve answering a question. All right. Well, a question that I often get is that about performance, and what either from two perspectives. One, which mesh is the most performant, but another one is how much of a performance impact does a service mesh contribute? And I think those are fine questions. One thing that must be stated as the backdrop before even answering that question is a microservices environment with this inherent networking, these inherent networking problems. Solving things like client-side load balancing, service discovery, timeouts, retries, circuit breaking, telemetry collection, and so on. These are not optional. So it's not like you can just say, well, I'm going to deploy microservices and I'm not going to solve any of those things. I'm going to gain huge performance benefits from that. Those are not optional things to solve. You have to solve them. If you don't, then you're walking into a dark room and you make changes to your services, and who knows what the hell happens, right? So those are not optional. So now the question is, how do you end up implementing that, and what are the trade-offs for doing that? Now there is some impact on any approach that you take to solving this problem. Generally, what I can say and what we've seen in the wild is that Envoy proxy should be able to run with a millisecond or sub-millisecond performance impact. So that if you think a Envoy on each individual workload will add approximately a millisecond of at least time overhead, performance overhead, that is, that's sort of where you should start looking. Now, if you take advantage of more features of Envoy and it's doing a lot of complicated things, then add more time. But that's sort of the arena that you should be thinking about or considering. Let me see. What are the parameters that we should use to evaluate a service mesh? And so I think, first of all, identifying what does your environment look like? As I covered, are you using VMs? Is it just Kubernetes? Are you doing messaging? Are you doing Akka and Scala? Are you doing gRPC? Right. So that's going to be a big indicator of what service mesh, or whether or not you should use a service mesh. I suggest strongly that you favor a service mesh that uses Envoy as its data plane, and then work back from there. If you need super high optimization, Envoy can be extremely optimized, and work back from there. Like I said, Istio is the most highly deployed, production deployed service mesh out there. I personally would advise people start with that and say, why not? Why can't I use Istio in this environment? And go from there. Let me see. Architecture with multiple shared proxies has become a micro gateway architecture by some vendors, while only one sidecar per microservice is a genuine mesh, right? So somebody asked the difference between a micro gateway architecture and a service mesh. And I guess that's going into a little bit more of the, what is a service mesh and what isn't. I've given a talk actually a couple years ago now at this point, I think it was the first service mesh con at KubeCon, that talked about the characteristics of a service mesh and its data plane. and specifically that the data plane can take multiple shapes, and the data plane that we know it as a proxy that lives with a particular instance of a service, but you could also have data planes that actually live in the application code. gRPC and some other libraries are able to understand the Envoy XDS API, and so your application can be natively tied into the mesh, or a gateway that lives at the edge or shared and so on. Those pieces can be considered part of the mesh as well. But generally, the pattern when you hear service mesh is that of the sidecar proxies deployed with an instance, but with an application instance. But that can be optimized for a particular use case that you might have. Okay, and then we also get questions like, can you go deeper into the deployment of glue mesh control plane? Keep the control plane. Right. Okay. So someone asked about the deployment of glue mesh, which is a distribution of Istio, and how you can deploy it to manage multiple types of service mesh, multiple clusters. And I don't think I have a slide for that, but typically you deploy the control plane separately from the data plane, and you remotely configure. The idea is to have these pieces decentralized, and sort of avoid the trap that we saw with the previous generation of technology, which is funnel everything through this big black box, and then we'll know everything. We can control everything and build a team around it and so on. But typically, the deployment pattern is to have a control plane separate. So you write your policies, you define your configuration. All the enforcement points happen out with the applications in a highly decentralized pattern. And the same thing with glue mesh, where you have the control planes and management planes separate from the underlying data planes. Somebody asked, what's the difference between Istio LSS and the one that glue mesh ships with? The difference is actually very minimal. So if you're running the Istio open source upstream in your environment, then running Istio from glue mesh is almost identical. You can use the same tools, use the operator, use the Istio CTL. You don't need additional tools to be able to run it. The main differences come in two areas. One, if you require FIPS compliance, so a limitation on certificates and algorithms and all these other things that the federal Federal Information Processing Standards, NIST guidelines suggest, we offer that with Istio, and there's some minor tweaks and changes that we have to make to get that to run if you're interested in FIPS. If not, it's about as close to upstream as you can get, with the exception, so this is the second part, that if something goes wrong, we are able to fix and patch the data planes and control planes in real time to get you back up and running in production. Now, the last part is, since we support Istio, for longer than upstream community, then there will be security patches and there will be additional fixes to versions in the N-2, N-3 range that diverge from upstream, because upstream doesn't support those anymore. But otherwise, if you're familiar with Istio upstream open source, it's almost exactly the same. So I think we're running out of time here. I do appreciate your attendance. I see some questions about eBPF. We can take that to let's take that to the Slack channel. But I've run out of my time here. Stay tuned for the next sessions. We've got a really good set of tracks here on more service mesh, more gateway, more WebAssembly content, and then of course for day 2 for more announcements. So thank you.